Ever pondered how a small nuclear atom has the power to light up an entire city or destroy it? The answer lies in a fascinating process called nuclear fission. Imagine an atom so minuscule yet brimming with an immense amount of energy. It's like a tiny, tightly packed ball of raw power waiting to be unleashed. Now picture the atom splitting apart, releasing that pent-up energy. This is exactly what happens in nuclear fission. Nuclear fission is like a game of cosmic dominoes, where one atom splits and triggers a chain reaction, releasing energy on a scale that's hard to fathom. It's this energy that powers our cities, drives industries, and yes, can also forge weapons of unimaginable destruction. The power of nuclear fission is both awe-inspiring and terrifying. It's a testament to the amazing and sometimes frightening capabilities of science. Now that we've sparked your curiosity, let's dive deeper into the process of nuclear fission. So, what happens during nuclear fission? It begins with a simple atomic collision. Imagine a neutron, a subatomic particle with no electric charge, hurtling through space. This neutron is about to embark on a collision course with an atom's nucleus. The atom in question is usually uranium-235 or plutonium-239, heavy elements with large, unstable nuclei. As our neutron smashes into the nucleus, it's absorbed, creating an even more unstable, heavier atom. This heavy atom can't maintain its structure, so it wobbles and then splits or fissions into two smaller atoms. This splitting is where the term nuclear fission comes from. Now, the fascinating part is what happens next. When the nucleus splits, it releases a staggering amount of energy. This energy is the same that powers our homes, drives our industries, and, unfortunately, can fuel weapons of mass destruction. But the energy isn't the only thing released during the split. The fission process also shoots out 2 or 3 additional neutrons, each moving with enough speed to hit another nucleus, causing it to also fission. This sets up a chain reaction where every fission event triggers more fissions, each releasing more energy and more neutrons. In a nuclear power plant, this chain reaction is carefully controlled to ensure a steady release of energy. But in a nuclear weapon, the chain reaction is uncontrolled, resulting in a catastrophic release of energy in a very short time. To give you an idea of the energy involved, consider this. 1 kilogram of uranium-235 can release as much energy as the combustion of 1,500 tons of coal. That's the power of nuclear fission. But nuclear fission is not just about energy production. It has also given us insights into the fundamental nature of matter and the universe. It has challenged and expanded our understanding of physics and continues to do so. That, in essence, is nuclear fission. But how does this process impact our daily lives? The energy released during nuclear fission has widespread applications, most notably in power generation. Imagine a world where a handful of uranium, a naturally occurring element, can power an entire city. That's the potential of nuclear fission. Here's how it works. In a nuclear power plant, uranium atoms are split apart in a controlled environment. This splitting, or fission, releases a tremendous amount of energy in the form of heat. This heat is then used to produce steam, which drives a turbine connected to an electricity generator. And voila, we have electricity. Now, why is nuclear power important? Well, it's incredibly efficient. A single nuclear reactor can generate around 1 million times more energy than a kilogram of coal. That's like replacing 1 million coal trucks with a single uranium pellet. Talk about a space saver. And it's not just about efficiency. Nuclear power is also a low-carbon energy source. Unlike burning fossil fuels, nuclear fission doesn't release carbon dioxide, the main culprit behind global warming. So, by turning to nuclear power, we can combat climate change while still meeting our energy needs. Of course, nuclear power is not without its challenges. There are concerns about nuclear waste, safety, and the potential for misuse. But advancements in technology are helping to address these issues. For example, modern reactors are designed to be safer and more efficient than their predecessors. And research is underway to find better ways to manage nuclear waste. But let's not forget, nuclear fission is not just about power generation. It's also used in medicine, for example, to diagnose and treat certain diseases. And in space exploration, nuclear fission provides a reliable energy source for long-duration missions. Nuclear fission, thus, lights up our homes and powers our industries. But it has a darker side, too. The same process that powers cities can also wipe them off the map. Welcome to the world of nuclear weapons. Nuclear fission, as we've previously discussed, is a process that harnesses the immense energy stored within the nucleus of an atom. But what happens when this energy is not used to light up homes or run factories, but instead is used to create weapons of mass destruction? Atomic bombs, the most infamous examples of such weapons, utilize the same principle of nuclear fission. They contain isotopes such as uranium-235 or plutonium-239, similar to those used in nuclear reactors. However, instead of controlling the chain reaction in these weapons, the reaction is allowed to occur in an uncontrolled manner, releasing an enormous amount of energy in a fraction of a second. This energy is then converted into a shockwave of heat and radiation, causing massive destruction. The destructive power of these weapons is unfathomable. To give you an idea, the bomb dropped on Hiroshima in 1945, known as Little Boy, exploded with the force equivalent to 15,000 tons of TNT. It obliterated 5 square miles of the city and killed an estimated 140,000 people. The second atomic bomb, Fat Man, dropped on Nagasaki 3 days later, was even more powerful. Its explosive force was equivalent to 21,000 tons of TNT, killing approximately 70,000 people. These two incidents serve as stark reminders of the devastating power of nuclear fission when used for destructive purposes. The consequences of the use of such weapons extend beyond the immediate destruction. The radiation released can cause long-term health effects, such as cancer and genetic damage, affecting generations to come. It also leaves the land uninhabitable for many years due to the residual radiation. Nuclear fission, thus, is a double-edged sword, capable of both creation and destruction. The choice of how we use this power is a critical one, with implications that could alter the course of our civilization. The decisions we make today will shape the world of tomorrow. So what does the future hold for nuclear fission? As we look to the horizon, we see a world poised on the brink of a new era, an era where nuclear fission could become a cornerstone of our energy production, powering cities, industries, and even space exploration. In the realm of energy production, the potential advancements are staggering. Picture this: small modular reactors dotted across landscapes providing localized, efficient power. These reactors, compact in design, could revolutionize the way we generate electricity, offering a more flexible and cost-effective approach to nuclear energy. But it's not just about our planet. Spacecraft powered by nuclear fission could journey to the farthest reaches of our solar system and beyond. This technology could fuel our dreams of interstellar travel, making distant planets and stars not just points of light in the sky, but destinations within our reach. Yet, as with any powerful technology, nuclear fission presents its own set of challenges. It's a force we must handle with the utmost care. The waste generated from nuclear reactors is highly radioactive and requires safe, long-term storage solutions. Furthermore, the potential for nuclear weapons proliferation remains a pressing concern. As we move forward, it's crucial that we strike a balance. We must harness the immense power of nuclear fission, but do so responsibly. This means investing in research to develop safer reactor designs, more efficient waste management techniques, and stringent regulations to prevent misuse. The future of nuclear fission is not without its hurdles, but with careful planning, rigorous safety measures, and a commitment to responsible use, we can turn these challenges into opportunities. As we peer into the atomic future, it's clear that nuclear fission will continue to play a pivotal role in shaping our world. It's a future that demands our attention, our ingenuity, and above all, our responsibility. Because after all, the power to shape this future lies not just in the atom, but in our hands.